We're going to cover 4.3, Part 2 today. There are objectives for 4.3. We're not doing 4.4 constructions. So median. The median of a triangle is a line segment whose endpoints are a vertex of the triangle and the midpoint of the opposite vertex, of the side opposite the vertex. So D, as shown by these hash marks, is the midpoint of BC. I connect A to D, the vertex to the midpoint of the opposite side, and that is our median. B. B is on the perpendicular bisector of AC. Find AB and BC. We can do this using the Pythagorean theorem because I have a right triangle. So I would say AB is equal to the square root of 3 squared plus 4 squared, which is equal to 5. It's a 3, 4, 5 triangle. So BC is equal to 5. Everybody have it? Yes, Shatis.
How exactly do we know if AB equals 5 and BC equals 5?
Well, we've got 3 and 4 here, right? So 3 and 4 are going to make this 5 by Pythagorean theorem. And we've got 3 and 4 here, right? So that makes this segment 5 by doing Pythagorean theorem on both sides.
Okay.
This is going to prove something about a perpendicular bisector that we'll use later.
Okay.
All right. Next example, H is the midpoint of VG. Find angle EHF. All right, so how we could do this is the two smaller triangles. How would they be congruent? Shatis?
By side on side? Right, no, side, side, side.
Yeah, side, 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 because they share the middle segment. So we have triangle EHF is congruent to triangle GHF by side, side, side. So the two triangles are congruent. So then we have, angle EHF is congruent to angle GHF. How do we know they're congruent? EHF and GHF? Yep.
By CP.
CP. So by CP we know they're congruent, corresponding parts. And so now we've talked about this recently. They're congruent. What else are they? And as a result, what can we conclude? Somebody besides Shatis. What can we conclude about, how can we find the measure of EHF given this situation? Chris? Yeah, they're supplementary and they're congruent, so I have to divide 180 in half to get each one. So we have, because they are supplementary, then angle EHF is congruent to angle GHF, and they are equal to 90. Questions there? Perpendicular bisector theorem. Okay, so these two examples have just sort of proven this theorem we're going to talk about now. The perpendicular bisector theorem says a point is on the perpendicular bisector of a line segment if and only if it is equidistant from the endpoints of the segment. Alright, so we know P is on the perpendicular bisector of AB because PA is congruent to PB, and vice versa. If PA equals PB, then I know P is on the perpendicular bisector of AB. Any questions? All right. Proof of the perpendicular bisector theorem. It is an if and only if theorem, so we must prove two parts. We've got to prove that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints, and so on. Okay, now, before we go on, let's go back to the theorem. This perpendicular bisector theorem works in three ways. It has three components. We have perpendicular, we have bisector, and we have equidistant. So if I have a segment that is, first of all, it's perpendicular and it bisects a segment, then I know P is going to be equidistant from A and B. That's the obvious way. Let's say I know P is on the perpendicular bisector, and I know that this AB is perpendicular to, or is bisected by this line that P is on. Then I could say, okay, this has to be a perpendicular. This has to be a right angle. Or I could have PA is congruent to PB, and let's add this, make this D. AD is equal to DB. Then I would know that, okay, that's the one I just talked about. Then I know that has to be perpendicular. If I have PA equal to PB, and I have a perpendicular line, then I would know that AD equals DB. So any two of the three components, if you have any two of the three, then you can use the third by the perpendicular bisector theorem. Now let's go about this business of proving it. Sub-goal 1. Prove that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So we have to show PA is congruent to PB in this picture. So we will do a two-column proof. It says paragraph, we're going to do two column. So step 1, AC, we're given that AC is congruent to BC because it told us that the P was on the perpendicular bisector. So that's step 1 is definition of perpendicular bisector. Step 2, angle ACP equals 90 degrees and angle BCP equals 90 degrees. So by step 2, we have, how do I know that those two angles are 90? Because I was given that it was a perpendicular bisector, so it's definition of perpendicular. So next step, step 3, I would say triangle ACP and triangle BCP are right triangles, and that's by step 3 is definition of right triangle. And then we know that step 4, we know that PC is congruent to PC. PC is congruent to itself, right? So you can mark that in figure B up above you, this proof. So now looking how what we have, how would I want to say that the triangles are congruent? Okay, Shatish.
Triangle ACP is congruent to triangle BCP by leg, or SAS.
Right, well, I have to use leg the way I've done it because I didn't say ACP is congruent to BCP. Okay. So, yeah, I went the route. I could have done it that way and done side angle side, but since I said that I used the fact that they're right triangles, then I want to use leg. So we would have step 5, we would say triangle ACP is congruent to triangle BCP, and that's by leg. Everybody with me so far? All right. Then let's clear this out. And finish it up. So we would have step 6, AP is congruent to BP, and that's by CP, corresponding parts. And then step 7, P is equidistant from A and B, and that's by definition of congruence. Any questions there? All right, let's prove sub-goal number 2. Sub-goal number 2, prove if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of a segment. So we've got PA equal to PB. We've got to prove that P is on the perpendicular bisector of AB. So, step 1. You can do this and refer to the drawing. We would draw a median PC, and that's by the median postulate. Anytime you draw something in, that's the postulate of whatever you drew in. So that's the median postulate. Step 2, what are we given in this? Let's hear from somebody else besides Shatish. What am I given? Nick, Ben.
AP is congruent to BP.
Yeah, we've got AP congruent to BP. And that's given. All right. And then from if PC is the median, what else do we know is congruent? Nina?
AC is congruent to BC.
Yes, good. AC is congruent to BC. And that's by definition of median. What else could we say is congruent in that triangle in figure B? Okay, Abby?
PC is equal to
Very good. PC, congruent to PC. And that's by reflexive property. Step 5. What am I able to say now? Okay, Nina.
Triangle PCA is congruent to triangle PCB.
By
Angle side side.
what have we shown as congruent?
Oh, leg.
We haven't established that they're right triangles. Anybody else? Yeah, go ahead, Ben.
Side, side, side.
Yeah, it's side, side, side. We show they're congruent by side, side, side. And we've got this side here, these two sides, and these two sides. There's my side, side, side. And then step 6. In step 6, I want to say angle PCA is congruent to angle PCB, and that's by, how do I know those two angles are congruent, Shatis?
CP.
CP. Yes?
We'd have a sentence one saying that angle ACP and angle PCA and PCB are both 90 degrees since they're congruent and supplementary.
Right, that's what I have to do next. I can't do that in one step, though. I have to do it in 2 steps. So that would look like this. We would have a step saying, step 7, we would say angle PCA and angle PCB are supplementary. And that's by definition of supplementary. Eight. We now know that angle PCA is congruent, is equal to angle PCB, and they both equal 90 because we have the theorem that says two congruent angles that are supplementary are right angles. Right? So then I can say step 9. We can say that now I know, since we've shown that PC is bisects and it bisects AB and it's perpendicular to AB, we can say that PC is the perpendicular bisector of AB, and that's by definition of perpendicular bisector. And then the last step is just a formality. We have to say what we had to prove. What we set out to prove is, does everybody have this? Can I go on? All right. The last step would be step 10. P is on the perpendicular bisector of AB. And that's definition of line segment. Okay, any questions, Shatice?
Could this have been proved by saying that the triangle is isosceles and that saying that if P were onto the perpendicular bisector, that we could say that a line drawn down from the vertex angle down is a perpendicular bisector?
Because it's an isosceles triangle? That would be side angle if you did it that way. I don't think you could do it that way.
Okay.
All right. So finishing up here, exterior angle. An exterior angle is formed by one side of a triangle and the extension of an adjacent side. So as illustrated in this figure, okay, we've extended side AC. The angle formed with side BC and this AC, this angle 3. Angle 3 is the exterior angle of that triangle. Now, if I extended BC, right, there'd be this angle. This angle is not an exterior angle. That's a vertical angle. It's a vertical angle with that. So don't call that an exterior angle. I could call this, where this letter C is, I could call that an exterior angle. But we're concerned with angle 3 right now. So the exterior angle theorem says the measure of an exterior angle of a triangle is greater than the measure of either of the non-adjacent interior angles. Non-adjacent means not next to. Adjacent means next to. Not next to. So the two angles in that triangle that are not next to 3 are 1 and 2. So we know that from this theorem we would know that angle 3 is greater than angle 1 and angle 2. Let's add to this. We're going to show. Oh no. I've got to get back to my slide here. We are going to show that angle 1 plus angle 2 is equal to angle 3. So this is saying that the exterior angle is equal to the two non-adjacent interior angles. We can show this by doing the following. We know angle 1 plus angle 2 plus angle 4 is equal to 180 degrees. Triangle sum theorem. The three angles of a triangle add up to 180. Angle 4, we'll add that to this picture. That's that angle, right? We know that angle 3 plus angle 4 equals 180 because they're a linear pair. They make a line, right? So now, since both of those two statements equal 180, we can say that, let's go up here, we'll say angle 1 plus angle 2 plus angle 4 is equal to angle 3 plus angle 4. Right? And then we would subtract angle 4 from both sides, and we'd be left with angle 1 plus angle 2 equals angle 4. That's the exterior angle theorem, right? And it says the two non-adjacent interior angles, 1 and 2, will equal the exterior angle 3. This should say angle 3, not angle 4. That should say angle 3. Right there. All right, any questions on the notes? No questions. All right, very good.